Hi guys, so this is a video overview of transformation and I'm going to be doing some problems from the study guide. I know I put a lot of transformations on there because it's just very important. So I'm going to start out by making a table. And I should make this red. It's kind of 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And then I have x, y, and that's 0, 0, and 2, 1, and negative 2, 1. Okay. So I have to see how that got transformed. And the 0, 0 tells us that there was no movement left or right or up or down. So we know that there is no adding or subtracting. Subtracting is the same thing as adding, except with negative integers. But there's no adding. Okay, so if you take a look, I can match these up right here. Okay, and you notice that the y's didn't change, but the x's changed. Okay, so how did the x's change? And the only option we have is to multiply, because the 0 hides whatever the multiplier, but it reveals the add-in. Okay, so we have to multiply by 2. Okay, and so 2, negative 2. And so my function is g of x equals, multiplying the x, open up the x function. X is complicated. There you go. Okay, and that will make it a horizontal stretch by scale factor of 2. Okay, now what's really interesting is that you guys are like, do I just match up random points? Well, you could have actually matched up these 2 points. Okay, in doing so, what you notice is that the x value didn't change, but then the y value did, and the y value, I multiplied this by 1 over 4. Okay, so I could rewrite that. This is the other option, or and multiplying it by 1/4 is going to be multiplying the x, so that is a vertical compression by a scale factor of 1/4. Okay, but then what's really interesting is that when you actually take this and you apply the 1/2 square and x square and take that 1/2 out of inside the function, then what you actually end up with is 1/4 x squared. And that's the same thing as that right there. Okay? So whichever way that you decide. Okay, another way to do that is if you're just gonna stick to, let's see. Yeah, if you're just gonna stick to, if you wanted to use the counting method, okay, to that first point, the counting method is actually up 1 and right 2. Okay, so up 1 and right 2. So that'll give us 1/2. But then we don't know what to put it on the x or on the y. Okay, so it doesn't really work always for all of them. Okay, because then it would have had to been 1/4 up 1 and to the right 4. But then if you notice that it's up 1 and to the right 2, and the original function is up 1 and right 1, you notice that the right changed. So left and right is multiplying the x. So in order to go from 1 to 2, you have to multiply it by 2. And then to put that into the function, that's going to be the reciprocals, that's 1/2. So you could have done it that way. But once again, making a table is just universal. It just doesn't complicate a lot of things. Okay, and so let's do the next one. Okay. Okay, so once again, I'm going to make my points x, y, 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And then let's see how it changed. 0, 0. Once again, we know that there's not going to be anything added. Nothing added. Okay. And then 1, negative 2, and negative 1, negative 2. And so I can see I could link these 2 points up right there. Nothing happened to the x. Something happened to the y, and it got multiplied by negative 2. So my g of x is going to be, it is going to be negative 2x squared, which is a vertical stretch by scale factor of 2 and a reflection over x-axis. Okay. Next, number 3. Once again, x, y, 0, 0, 1, 1, negative 1, 1. I'm just going to go to there, and then x and y. Now this time, the vertex did move. It's now 3, 2. And then another point would be 4, 3. And then a 2, 3. Okay, so I can first test this point from here to here. We can say we add 3 and add 2. Okay, but if I go ahead and add 3 and add 2, I know that 3, 2, and then 4, 3, and let's see, 2 and 3. That actually works. So once again, this will work up 1 and right 1. It's still 1, 1, so a value did not change. So my function is g of x equals x minus 3 squared plus 2, and that would be up, vertical shift up, 2, and right 3. Okay, next, let's take a look. X and y, so we have 0, 0, 1, 1, negative 1, 1. Okay, and then 2, 4, negative 2, 4. Okay, x and y. So I have a negative 3. That's my vertex. It moved. And then a very good point is going to be all the way up here. So I see a negative 1 and a 1. And a negative 5 and 1. Okay. What I'm going to do is I'm going to match that point, these two points with each other. So what I could do is I could subtract this by 3 and subtract y by 3. And what I end up getting is a negative 3, negative 5. and then a -2, -4, and a -4, and a -4. I know that that's not the same as the ones that I matched up. So I know that there's some kind of multiplication going on. So what I'm going to do is I'm going to make an equation. Okay. And what I'm going to say, this is the final. This is the end result. This is the end result. So that end result, okay, of 1 came from this 1. Okay. Let me go ahead and put it in a different color. That 1 came from 1. So I can make an equation that says 1 came from 1, but -5 had to be added, okay, to the 1. But something had to multiply it. So we're going to say A multiplied 1, okay, and then subtracted it by 5. Okay, so I'm going to do +5. So A equals 6. Okay, A equals 6. And so I can get my A value. And if I test it out and multiply this first by 6 and then add 5. 6 times 1. Yeah, it's still going to give me that. Okay, so that worked. Now I'm going to make another equation using the x value. And I'm going to say that -1 ended up becoming -1. I have to multiply it with a b value times 1. It started out as 1, but I had to subtract 3 from it because that's what happened to the vertex. So I get +3 + 3. So b equals 2. Okay, I could do it that way. And then my function gets created. Okay, so I could test it out also. So that's going to be times 2. So 2 times 2, and then subtract, yeah, that becomes -1. 2 times -1 is -2 minus 3 becomes 5. It works. Okay, so that is going to be a 6. Whoops. 6 multiplying. And then we had a 1/2. And that's the factored out form. X. Okay, and then a +3 squared, all of that squared, and then -5. Okay, now this could be the final answer, or let's go ahead and take that 1/2 out of there. So I get 6 and then 1/2 squared, which is x plus 3 squared minus 5. That's g of x. So that becomes 6 times 1/4 x plus 3 squared minus 5. And that's going to become 3/2 x plus 3 squared minus 5. 3/2. So 1, 2, 3, and 1, 2. Okay. So that works out perfectly. Okay. Now another way of looking at that is counting. I went up 1, 1, 2, 3, 4, 5, 6. So 1, where we just counted up 1. Okay, so it became, before it was 1, and it changed to 6. And you could clearly see the scale factor. So how does 1 become 6? You multiply it by 6. There's your vertical scale factor. And then, before it was just right 1, but now it's right 2. How did that 1 become a 2? you multiplied it by a 2. Okay, you can look at it that way, and you can separate that out. Instead of thinking about slope in that way, thinking about the rise over run and the scale factors for each. Okay? Hi guys, so this is going to be on your key, and it's just straight. This is just a little bit of fun, but it's really probably not fun for you this week. I'm sorry. Yeah. But I'm going to move on to here and maybe introduce a new way of maybe looking at these graphs that we didn't really talk about in class. One of the things that you can also, instead of making a table, what you can do is first look at the vertex. Okay, so the vertex went from 0, 0 to 1, 4. So it means that it went from 0, 0 to 1, 4. And I remember this is the first year I taught it like this. But then I came up with a table method for those of them people that really needed kind of a step-by-step process of doing it. And so this is from the Desmos. And so if you take, I know that g of x got created by f of x. And so we can go ahead and put our add-ins. X is complicated. And then we added 4. Okay, now remember the first notable point on the quadratic is going to be it's going to be up 1 and right 1. But if you take a look for this one, we go up 1, 2, we go up 2, and then right 1. We go up 2 and right 1. Okay, so we take a look. The up is going to be the A value, and the right is going to be the B value. So right is going to multiply X, and up is going to multiply Y. Okay, so how did that increase? You get it multiplied by a 2. Actually, we went down, sorry. Down 2. Okay, and so it multiplied by a negative 2. Okay, so what I could do is just take that A value and multiply the Y. And the X did not change. There was not a multiplier. Okay, so I could just go ahead and write that equation just like that. And that is the right equation. Okay. This one, now if you look at the inflection point right here, if you look at the inflection point and see how it moved from 0, 0 to negative 2, 1. And so that means that my g of x got created by my f of x, and x is complicated, and then added 1. And now, if you look, it was up 1 and to the right 1, up 1 and to the right 1. Okay, to get to a good solid value for this, you have to go up 2 and right 1. My x value did not change, but my y value got multiplied by 2. So I can go ahead and add a 2 in front of my y value, and that is my correct answer. Let me go ahead and all this. Okay, next one. Okay, so if I look at my vertex, how did it move? It moved from 0, 0 to negative 3, negative 4. So if I start creating my function, it's going to be g of x that got created from f x plus 3 minus 4. And now I'm going to count. We went up 1 and right 1, right 1. But to get to this point right here, we went up 1 and 1, 2. Up 1 and right 2. Okay, so right 2 means it's a multiplying the x value by a 2, but we have to take the reciprocal of it. And it has to be factored out. So I end up with a 1/2 x plus 3 minus 4. And that's my final answer. Okay? Okay, so there's the vertex. And that's the vertex right there. It's really, yeah, we still call it a vertex. So it went from 0, 0 and 5, negative 1. So my g of x got created from my f of x. X is complicated, minus 1. And then to get to that first point right there, it's going to be up 1 and to the right 1. To get to first good integer, we have to go down 1, 2, 3, down 3, and right 1. So how did that happen? We multiplied it by a negative 3. Remember, up or down is the y. That's 3, so it's going to transform that into negative 3 f of x minus 5 minus 1. So I want to thank Arjit for helping me remember how I used to teach this instead of making a table. And so that might be alternative way for you to do these problems instead of making a table. Okay, so remember there's not going to be any rational functions on the test, but this one, the asymptote, got moved. So you have to look at the asymptote on rational functions. And so that's the asymptote. So the asymptote got moved from, basically, you can plot a point 0, 0 to now the negative 4 and 6. It got moved from there. So we know that this is going to be g of x equals f x plus 4 plus 6. Okay, and then when you actually look at the graph from the asymptote, or from the intersection of the asymptotes, it goes up 1 and to the right 1 once again, and from that intersection of that asymptote, it goes up 1 and to the right 1. So you know that there's not going to be any kind of dilations. Okay, next. So if we look at the vertex to this new vertex, I could make an equation, and this they wanted it in absolute value. So from 0, 0 to negative 4, it's going to go x plus 4 minus 4, x is complicated, and then down 3, and then we went up 1 and right 1. It's my cat. Okay, but for this, we're going to go up 1, 2, 3, 4, 5, and right 1. Up 5 and right 1. So to get from there to there, we multiply the y's by a 5. So x equals 5, x plus 4 minus 3. That's going to be the final answer. Okay. Next. Okay, so that's a cubic function. Okay. I think that's a cubic function. Yeah. That's a cubic function. And this, is it a cube root function? I think it might be a cube root. Okay, so let's do this one. I think that's a square root function. And you notice that that vertex moved from there to there. So I can create my g of x equals, and it's a square root function. So it is going to be x. X is complicated, so minus 5 but plus 5, and then minus 2 outside of the function. Okay, if you take a look, it's a 1 up and 1 to the right, but we did 1 down and 1 to the left. So 1 down from 1 up, right 1, and so it's going to be a down 1 and right 1, so we're going to multiply it by -1. There you go. That's the final answer. Okay, now if you take a look at this vertex right here, and then if you take a look at that vertex right there, and then we can see that this is a cube root function. So I'm going to make my cube root. Okay, and we went right 3, x is complicated, and down 1. And then if you notice that we just have to go up 1 and to the right 1, up 1 and to the right 1. Nothing else changed. That was it. Okay, next. This is a cubic function. So g of x equals, now that vertex, that inflection point, move to that inflection point. So left 1, x is complicated, and then up 3. Okay, now we move up 1, and right 1, but this time we moved up 2 and left 1. So y has to get multiplied by 2. So that's going to give me 2 in front. And then it went down, so we multiply it by a -1. We multiply it by a -1, but it has to be in its factored form. There you go. Okay, I think this is much simpler if you're just looking for the equation of transformed functions. Okay, next, g of x. Okay, let's see where that vertex moved. I think it moved from there to there. So 0, 0 to 1, 2. This is a quadratic. X is complicated. Okay, plus 2. And then you go up 1 and to the right 1. Up 1 and to the right 1. But this time we went up 1 and right 2. So we multiplied the right by 2, which is multiplying the x by 2. That's y. But then we have to take the opposite, because once again, x is complicated, and we have to do it in its factored form, just like that. And that's its final answer. Okay, so yes, you can use the table, but then you also can use this method too. Okay, I'm going to put the rest of the key up for these if you want to do them. Okay, it's just pretty much the same thing as the other ones, but good job. And guys, hang in there, okay?